Basics of AngularJS. Hello everyone, this is Ben Finkel, and in this nugget, we're going to take a look at AngularJS from a very broad basic level. Before we get down into the nitty-gritty details and start really working with it, we want to make sure that we understand what AngularJS is and what it's trying to do and how it tries to do that. So to that end, we're going to start off talking about AngularJS at the 50,000 foot level. And what do I mean by that? Well, we talk about AngularJS as being a client-side JavaScript MVC framework, which is cool. That's a lot of great words, but what do those words mean? So we're going to talk about each of those things and what it means for AngularJS. We're going to take a little bit of a deeper dive into MVC, the design pattern itself, and see how Angular implements MVC, what Angular does to implement that MVC design pattern. Then lastly, we're going to finish up with finally writing some actual code, and we are going to write, that's right, a Hello World application. Going to show you how to implement the Hello World application in AngularJS, and we're going to compare and contrast it to a couple other samples in some other solutions. Alright, I hope you're warmed up and ready to go. Let's get started. To begin with, we talked about AngularJS being a client-side framework. So what does that mean for us as the developers? Well, it means that all the execution is happening on the client's desktop, on the client's PC. We don't know what browser they're using. It could be Internet Explorer, it could be Firefox, it could be Safari. We don't know what operating system they're running. Maybe it's Windows or Macintosh. We don't actually even know that it's a desktop. It could be a phone running Android or iOS. So all these things are possible, and we really can't depend on or count on anything from a developer standpoint being available to us on that desktop. The only thing we really can count on is that it's running in a web browser and that it's executing JavaScript. Without those two things, nothing's going to work, so we have to sort of assume that at a basic level. Outside of that, everything else is fair game. It also means that we're going to assume Angular as part of a broader technology stack, that it's just one piece of the puzzle when you're developing a web application. We don't expect AngularJS to handle, say, data storage, because you don't want to store data on your client's PC. You want the server to do that. We also are not going to expect AngularJS to serve up web pages. Again, that's for the web server to do. We expect AngularJS to be the output of that service, but we don't expect it to do that service itself. So during this video series, we're not going to really focus on those things. Late in the series, we will take a look at one example of integrating it with a web server, but that's really only so that you can see how it works and you can take that knowledge back and integrate it with your own web service and your own technology stack. We've also said that AngularJS is a JavaScript framework. So what does that mean for us? Well, it means all of our code has to be written in JavaScript. We don't get to write C# or Python or Go or any of that. We have to learn how to read and write JavaScript if we want to effectively make AngularJS web applications. Now, don't worry if you're only a little bit familiar with JavaScript. We're going to go over it a lot in this video series, and by the end you'll be an expert, I promise you. It also means that our code is being executed by and inside of a web browser. Now this has two really big important implications for us. The first, we don't have access to the same kind of low-level application interfaces that we might with a traditional compiled piece of software running on the user's desktop. We don't get to read and write to the file system. We don't get to write to the video memory, that kind of thing. We're working through the web browser. We're restricted by what the web browser lets us do. The second implication is that our users are going to have their own expectations, their own notions about how this software should work. After all, it's in a web browser. So they're going to expect to navigate using URLs. They're going to want to bookmark those URLs. They're going to want to use the forward button and the back button. They're going to want to refresh the page. And we want to make sure that our application responds to those events intelligently and appropriately, so that we don't impair the user experience. We don't confuse our user by dealing with those things differently than they otherwise expect. Lastly, we talked about AngularJS as being an MVC framework. MVC stands for Model View Controller. Now MVC is really cool. It's a really important part of AngularJS, and it's important for us to know how to use it. So we're going to spend a few minutes here talking about what exactly that means. The first thing to know is that MVC is a design pattern. In software engineering, a design pattern is an abstract way of thinking about your code or writing or organizing your code. It's not code itself, and it's not a library, it's not a function, it's not any sort of compiled thing that you're accessing. It's just a generic language-independent way of thinking about your code. You may remember from computer science class you learned about stacks and queues or linked lists, and you talked about those things before you wrote them in code, and everyone talked about them, everyone learned about them. It didn't matter if you were learning Java or C or C++ or Visual Basic. Whatever code you were writing in, you were going to implement those things, but first you just talked about the design pattern of a linked list. You talked about what it was that you were trying to accomplish. MVC is kind of the same thing. But where a linked list was a really specific, narrow pattern designed to solve one particular problem, Model View Controller is a broader, more abstract design pattern. It's all about how to organize your code, how to structure your code. And the goal of that structure, the goal of Model View Controller, is separation of responsibility, separation of duties. You might have run into design patterns like this before for code. N-tier is the one that comes to mind for me. In an N-tier application, you had your three layers. There was a presentation layer, a business logic layer, and a data layer. And the reason you do that is so you could swap out tiers. You could change out layers in this software without impacting the rest of your software. You could, say, switch from Oracle DB to MySQL just by changing out that data layer and then presenting the data in the same fashion your old layer did, and the rest of the software, the rest of the program would function as is. You wouldn't have to worry about retesting the rest of that software. The point of all that was to create separation of responsibility, separation of duty inside your code. Each little piece of code, each library, each tier was responsible for one particular thing, and so if you needed to change how that worked, you could just focus on that one piece of code. MVC is kind of the same thing. It works a little bit differently, but the main idea is to get a separation of duty, a separation of responsibility in your code. The way I like to think about it is a bucket line. That's a kind of old-fashioned reference. I think maybe I've only ever actually seen it in old Western movies, but you're probably familiar with the concept. There's a fire that needs to get put out, so you've got one person standing over by the river or the well, filling up buckets full of water. He's handing those buckets off to a second person who's over by the fire, dumping the buckets out onto the fire to help put it out. And these two people have a very clear, distinct separation of responsibility, separation of duties. The first person, let's call him Charlie, is only responsible for scooping up water. Then he looks and he figures out which direction he's going to send that water. Is the fire bigger to the left or is it bigger to the right? He hands the bucket off in that direction, where the second person, let's call him Victor, is only responsible for pouring that water out onto the fire. That's all that Victor has to worry about. It's important to note here that they're both dealing with buckets, they're both carrying and lifting buckets, and they're both worried about the water. So no one is insulated from any part of the process. It's just that they're only worried about handling one particular part of that process. This is how I like to think about MVC, Model View Controller. In a Model View Controller application, you've separated out your code into these distinct roles and responsibilities. So take Charlie, your controller. That's responsible for program logic and program flow. It's scooping up the bucket of water and handing it off to the view. And the view is responsible for dumping that bucket of water out on the screen for the user to see. In this little analogy here, the bucket is actually the model, and the water is the data. And that's how you separate out, that's how you split out the responsibilities for each of these pieces of code in your software. Unlike that N-tier design pattern that I talked about, where different layers may be insulated or totally isolated from other layers, in MVC, everyone kind of knows about everyone else. The M and the V and the C are all aware of each other. So a controller needs to know what views are available to it, that it can invoke, that it can use to display the results of the user interaction. The view needs to know what functions are available in the controller that it can provide buttons to the users to click. So when the user clicks button X, it needs to know that it has to invoke function Y inside of a controller. And both the view and the controller need to know about the model. They need to know about the data structure and what data structures are available. The controller so that it can manipulate that data, and the view so that it can display that data appropriately on the screen. Now this is maybe best understood with a quick example. So imagine that you're a user and you want to delete a record out of a database. Let's say you're deleting a customer record. You're staring at a screen with a list of records on it. That's your data set. And each one has a little delete button next to it. You click one of those buttons. Now the view has to register that button click and say to the controller, hey, the user wants to delete. So it invokes the delete action on the controller, and by the way, here's the record ID of the record they want to delete. The controller takes that action, it takes that information, and it goes ahead and deletes the record out of the record set. Refills up the model with the resultant record set, which is just the same records less that one record. Hands that new model, that new record set, off to a new view, and the view dumps those records back out on the screen. So now you as the user see the same record set less than one record that you've already deleted. The model, the view, and the controller each had their own responsibility, their own job in that process. So let's talk a little bit about how AngularJS implements the MVC framework. MVC is an old framework, it dates back to the 1970s, but it's had a recent resurgence in popularity. And that's due to the fact that it fits internet development, web development, really well. Here's the reason for that. You can have your controller sitting on in your server executing in whatever code you want your controller to execute in, ASP.NET or Java or Ruby, you name it, it'll do it. It can grab data right out of the data model or right out of the data repository and put it into your model, smoosh that model up into the view, smoosh being a technical term, and send it down to the client. Down here is our client. And in between the view and the client is the internet. So this kind of setup makes a lot of sense, right? When the client clicks a button to make a new HTTP request, that's just sent back over the internet to the controller, and the whole process starts over again. As a developer, you have complete control on the server side of what you want your back-end code to be, what you want MVC to be executed in. AngularJS doesn't really fit into this framework, this model of an application, though. Remember, Angular is running entirely on the client, so we don't have a server side. We don't have access to all that great server-side technology. We don't get to read and write from databases with Angular. We only get to render views to the screen. So to that end, I like to think of AngularJS as being focused on the V part of this MVC model. And here's what I mean by that. Regardless of what technology you're using on your server, at some point you need to create output for your user's screen, and that's HTML, CSS, and JavaScript. Well, Angular gives you a way to create really powerful output, not just straight HTML, but actually templated HTML, to send the data down with that HTML and have that smoosh operation happen on the client side. In fact, you get a little MVC application inside of the view right on the client side PC. And there's good reasons for doing this. The more data, the more functionality that you can offload onto the client, the fewer interactions with your server the client needs to perform. And that's good in web development and internet development because those interactions with your server have to happen over the internet, which is often unreliable. You don't know if your users are sitting at their desktop on a high-speed internet connection or driving down the highway using their phone. You want to make sure that they have the ability to do as much as possible right there in their client workspace as they can before having to interact with your server again. It also allows you to take care of regional differences right there on the client execution engine, so dates and numbers can be formatted properly, or you can make sure that you're displaying appropriately for the type of device that they're viewing it on, a large desktop monitor versus a small mobile phone screen. In order to make all of this work and still keep it simple for us as web developers, and that's one of Angular's mission statements, is simplify the web development experience, the folks over at Angular have done some really neat stuff. To start with, they've implemented controllers as JavaScript functions. Now, this makes sense if you think about it. JavaScript is the only code we really have access to in Angular. It's the only thing that's going to let us handle program logic and program flow and respond to user events. So controllers are JavaScript functions, but one neat thing is that they are plain old JavaScript functions. What I mean by that is in a traditional MVC web application, the controller sits on the server, has to inherit a library or inherit functionality from some sort of controller object. Not so with Angular. In Angular, the controller is just a plain old JavaScript function that you define yourself. Any additional functionality that it needs to integrate with Angular, it gets through the miracle of something called dependency injection. And we'll talk about dependency injection in depth in a later video, but you're going to see us use it a lot during these basic videos. It's pretty cool stuff. Now, sticking with that theme, models in AngularJS are just JavaScript objects and JavaScript properties. Remember, a model is just a container for our data. It's a bucket in the bucket line analogy, so it doesn't need to do anything other than hold water. And JavaScript objects are perfect for that. Just like above with the controllers, these are plain old JavaScript objects. I'll call them POJOs. And again, what I mean by that is they don't have to implement or integrate anything else in order to function as a model in an Angular application. Dependency injection is going to get us all the functionality that we need. Now the final piece, and I would argue the biggest piece of an AngularJS application, is the view engine. Recall in an MVC application, the view engine is responsible for doing the smooshing of the model and the view into something that can be rendered on the user's screen. It's the person in the bucket line who's dumping a bucket of water out onto the fire, except it's dumping a model full of data out onto the user's screen. Now we know the output from this is going to be HTML because we're running inside of a web browser, and that's what they use to display. But what's the input going to be? Well, the input is also going to be HTML, or an extended version of HTML, and is done through something called the document object model, which is just another way of looking at your HTML document. If you're not familiar with it, we're going to go over it right now. Don't worry, it's real easy. So the document object model is just a way of thinking about your HTML code. Take a look at the code I've got up here on the screen. It's pretty simple, pretty straightforward. There's a few elements, a few nodes, and some attributes, and some text. Well, each of those things can be thought about in a parent-child relationship, and we call that parent-child relationship the document object model. We treat the whole document like a bunch of objects, and they each have a relationship to one another. So you see this tree view here down below. Each one of these squares represents some object, some piece of our document. And you've kind of thought about this if you worked with CSS, right? When you apply a CSS style to, say, the body, that style cascades down to all the children objects of that body. Unless you overwrite one of those children objects. So you overwrite here, then that one cascades down to fill in all those objects. So you've already kind of thought about your HTML document object model. It's going to become much more important when we talk about integrating the Angular view engine into your document. And that's because Angular extends the document object model. It extends the vocabulary of HTML. So rather than learning a whole new language, a whole new syntax to write your view engine, you just use some new attributes and some new elements right inside of your HTML document. This, combined with the fact that the controller and model are plain old JavaScript objects, means that you can produce Angular output from an existing technology, an existing server-side engine, very easily, no matter what that server-side engine is. All right, we've done a lot of talking, a lot of theory, a lot of scribbling on the page, but I promised we'd get our hands dirty, we'd get into some code, so let's get our Angular Hello World on. To start with, I'd like to take a look at a couple of different ways to build the Hello World application that I've designed. And I've designed a pretty simple, straightforward Hello World application. It's just an input box where you key in your name, and then a label below that says hello, whatever your name is. My name is Benjamin. So whatever you key into that box is what comes out. And it's pretty nice, pretty simple, pretty straightforward. But there's a lot of different ways that we can do this inside of a browser with HTML and JavaScript, so I want to look at those different ways. This first example that I have up on the screen here in JS Fiddle is using pure JavaScript. It's straight JavaScript code. There's no extended libraries, there's no additional functions. This is just JavaScript. And remember, everything that we do in Angular, because it's straight JavaScript, we could theoretically do ourselves without the fancy libraries, but I'm going to show you why we don't want to do that. Take a look at this code on the screen now. It violates a lot of the rules, a lot of the best practices of good programming design and good software and JavaScript development. For instance, the update label function is defined right inside of the global namespace in JavaScript. Blah. We don't want to define things in the global namespace in JavaScript. As our web application gets more complicated, that namespace is just going to get more and more crowded. The update label function is kind of generic. It may turn out that, we have other labels that we want to update. Suddenly, what are we going to name those functions? Update label 2? That's not very clear or very handy at all. Then on top of that, notice that the update label function is referenced right inside of our HTML itself. OnKeyUp equals update label. If we do realize that we've got our global namespace too crowded and we want to change that update label function to something more specific, more intelligent, well, guess what? We'd have to change it in two places. We have to go into our code and change it. We also have to go into our HTML and change this label. Conversely, look at the JavaScript itself. It's got a couple of references to the ID elements, the ID attributes of the HTML. The text and the world ID. Those are references specifically to the document object model, the DOM, inside of our JavaScript. Again, if we have to change something in our DOM, if we have to update our document object model, we also have to go back into our JavaScript code, find anywhere those things are referenced, and update them there as well. So this is really poor design, really bad code. But hey, you know as well as I do that you're not going to write straight JavaScript to do these kinds of things. There's too many great libraries out there that you can use to make the job easier. I've got one example up here on screen now. This is the same application, but I've written it using jQuery. Now, jQuery is a really powerful library. I don't want to disparage it, and it actually does a lot of things great. It would make sense to integrate it with your Angular application. But it falls into a lot of the same pitfalls that the earlier JavaScript code did when trying to accomplish the same kind of thing that we want to do, the same sort of interactive web application that Angular is so great at building. So take a look here. To use jQuery, all we've had to do was create a reference to the jQuery library, and then we were able to take that onKeyUp function, that reference to the JavaScript code, right out of the HTML. So already our HTML is a little bit cleaner. It looks more like HTML, and it's not so worried about the JavaScript code. It lets JavaScript worry about the JavaScript, while HTML worries about the HTML. On the JavaScript side, you can see that we're no longer inside of the global namespace. We've built our functions inside of this document ready function. And that's kind of nice. It gets things a little bit more organized, a little bit cleaner for us. And this code works as is, just like it did before. I can type in my name, I can paste in a name, and you see it updates right away. It's actually even a little bit faster than the straight JavaScript is updating, which is kind of cool. But it's still not super ideal. We've got to reference our document object model still inside of our jQuery. You see the input pound text and the span pound world. Those are again references to the DOM right inside of our JavaScript, when we'd really rather not do that. As much as possible, we want to avoid intermingling the JavaScript and the HTML. It's also nice that we have our document ready function, but that's all of the scope. That's the only space that we have. And it's almost as bad as using the global namespace because everything has to happen inside of that document ready function. What we'd like is some kind of scope hierarchy or scope structure so that we could worry less about naming conflicts, about collisions between different objects. Things would only be in scope when they needed to be in scope. That's a better way to build an application. Another issue here is something that the jQuery example shares with the earlier JavaScript example, and that's the fact that we're setting the text of that span element directly from the text of the input object. We don't have any kind of variable in our background in the JavaScript that we can use to look at or manipulate this. We'd have to create one and assign it. And secondly, if we wanted some more complex HTML inside of that span, well, then we'd kind of be stuck. We'd be building HTML strings or manipulating HTML strings inside of our JavaScript. That would get ugly very, very quickly. We want our HTML to be our HTML and our JavaScript to be our JavaScript. Alright, I've kept you waiting long enough. Let's take a look at the AngularJS version of my Hello World application. And here it is on my third tab in my third fiddle. This is the AngularJS version of the application. You'll see that it works exactly the same as the other two. I can type in, paste, the Hello World updates immediately. Now the first thing you'll probably notice is that there is no JavaScript for this Angular application. It doesn't require any JavaScript to make this happen. And that's because one of the main points of Angular is to simplify the web development experience. To that end, they've taken things that you might frequently want to do. In this case, we're doing some data binding. And they've just rolled it in. They've just made sure that it happens automatically for you. So when I key something into this box, that's actually being written in the background into a variable in JavaScript, and then being output automatically inside of my h1 element. So let's take a look at the code and see how AngularJS is doing this. To begin with, I'd like to point out that if you just looked at the code briefly, you might not notice anything amiss. It might look like straight HTML to you. And that's because, like we said, Angular is extending the vocabulary of HTML. It integrates itself with HTML to create dynamic templates that are still legible, still easily readable, and still easily recognizable as HTML. Just like jQuery before it, the only thing that you need to include in order to use Angular is a reference to the angular.js library, which I've done here. After that, take a look at my input and my h1 elements. On my input element, I've got a custom attribute called ng-model, and I've set it equals name. And all that's done is that said, hey, whatever value goes into the input box, store it in the background, store it in JavaScript in a variable called name. On the h1 element, I just reference that name variable inside double curly braces. Those curly braces are effectively how you tell Angular to evaluate what's inside of here. Don't just write out the word name, but actually evaluate what's inside of these curly braces and treat it like JavaScript code. In this case, the name variable is in there, so it's outputting the name variable right on the screen. And that means that whatever I type into my input box gets stored in that name variable and written out on the screen for us to see. So there you have it, a fully fleshed out, fully functional AngularJS application. It's pretty cool. It's real simple, real clean, real easy to do. You might be saying, hey, I thought it was an MVC application. Where's all the M's and the V's and the C's? Well, right there in front of us. The view should be obvious. That's the HTML document. The hello curly braces name is our view engine. That's our dynamic templating, creating the output hello Joe. The model is there as well. The name variable is our model. That's all we've done is said ng-model equals name, and we've created a model. We've created the name variable to store that value in. The controller is a little more sneaky. Because we, as the developers, didn't have anything specific to do that Angular wasn't already doing for us, we didn't have to define and build a separate controller. It implicitly created a controller in the background to handle the work, to handle the job of getting this value and writing it out to the screen. So again, in the aim of simplifying the web developer's experience, we didn't have to build an empty controller to do nothing because we had nothing to do. It did it for us. Throughout this video series, you're going to see that theme come up a lot, where Angular is simplifying things and doing things for us, and we need a lot less code to accomplish a lot of common tasks than you might in other web development frameworks. It's really cool. It's so much fun to work with. I think you're really going to have a blast. Okay, we've covered the basics of AngularJS. Let's take a moment to review. We talked about AngularJS from what I called the 50,000-foot level. We discussed the fact that it's a client-side JavaScript framework, and what that means is that it runs entirely on the user's device, their tablet, their desktop, their phone, whatever. Also, because it's JavaScript, it runs entirely inside of a web browser. We're limited by what the web browser allows us to accomplish. We also discussed the fact that it's an MVC framework. MVC stands for Model View Controller. And Model View Controller is a design pattern that helps us understand how to architect and organize our code to keep appropriate separation of responsibilities. We looked at how Angular implements MVC, with the model and the controller being inside of JavaScript, being plain old JavaScript objects, and the view being an extension of the HTML document object model. Finally, we finished up looking at a Hello World application, and we looked at it 3 different ways. Once with straight JavaScript code that was pretty ugly, a second time with some jQuery code that was better but still had some issues, and then a third time in AngularJS, and we saw how cleanly and how easily AngularJS allows us to build really rich, interactive web applications. Thanks everyone for watching, and I hope you found this informative.